So we've learned about why polynomials matter. We learned about how they help us describe and analyze that messy world around us. And we've also learned about a good approach for understanding these polynomials, the polio approach. And it's one that we've been using since way back in 5th grade. But we also learned that if we don't believe in ourselves and if we don't believe that these methods will make us more efficient problem solvers, that, well, in a sense, we don't believe in what we tell ourselves, well, then we just don't do it. So what I wanted to work on today is in this experience on how we solve polynomials, I wanted to look at a problem that can help us see that structure can actually help us solve problems more efficiently than just jumping in and doing something. And one aspect of the polio problem-solving template that I wanted to explore today was heuristics, that the rule of thumb solving approach to polio. The idea that we can come up with a set of rules that help us solve problems more efficiently. And hopefully as we see how this works and that it is more efficient, more accurate, we will again start to more and more believe in this polio approach. Okay, now I found this problem while reading a book on cognitive science and mathematics. And the author, he's a teacher, and he said that many of his problem solvers got lost chasing wild mathematical geese and never made it to an answer for this problem. So I thought this was a perfect one to solve using a structured approach. So let's jump in. So students were asked to solve the algebraic equation x squared y plus 2xy plus x minus y is equal to 2 for y. The first step with polio's problem-solving process is to always make sure that we've got a mental image of the problem, that we can actually describe the problem in our own words. So you don't see me right now, but I'm not looking at the text, but I remember that the problem is to solve x squared y plus 2xy plus x minus y is equal to 2, and then I'm solving this equation for y. So let's bring this into our problem-solving template. So the first step is I'm going to write this problem down. So we had x squared y plus 2xy plus x minus y is equal to 2. So we usually take the problem and put it into a simpler problem. When I look at this polynomial, it's pretty much in standard form. I could always bring that 2 over, make it a negative 2, and bring it to the left side so that the right side is a 0, and that would put it into perfect standard form. But, you know, this is asking me to solve for y, and it's not that important because I'm not factoring. So I don't really care about the 0 product property to get that 0 on the right-hand side right now, so I'm going to hold off on doing that. So I want you to take a second, put this on pause, and see what you notice about this equation. Take a look back and jot down one thing that you notice, and then come back. So what I notice when I look at this problem, I notice that usually I'm solving for x. I know that it's not odd that we're solving for y. It's just that with all of the factoring we've been doing, that I've gotten so used to the fact that we're looking for an x, a y-intercept. And here we just have to solve for y. And the second thing I noticed, though, is that y is of a 1 degree. If I look at the y in the 3 terms that is located in, it's y to the 1st degree. It's only in 1 degree, whereas x is squared and it's x. So it's just another thing I'm noticing, that y is 1 degree. I just want to put a note on that. Okay, so let's understand this polynomial. what do we know about this polynomial? Well, it's got 5 terms. 1, 2, 3, 4, 5. 5 terms. So this is a 4 plus term polynomial. It has a leading coefficient of 1, so I'm not too worried about that. It is a quadratic. It's got that x squared. Anything else that we're noticing about this? I'll take a look back at my questions, the type of values, and the solution set. Well, I'm not trying to solve for an intercept. I'm trying to solve for y, so I'm expecting to get an expression. So it should be that y is equal to some type of expression. Let's consider y a function. And the last set of questions I want to think about is, what do I need to be monitoring for? Is this an obvious answer? I don't think so, because it's 5 terms. I think it's a reasonable problem. I can't see how we're not going to be able to solve for y. Does it look tricky, though? Yes. So I do want to be monitoring. I want to be very careful, because this might be a tricky problem, and I want to quickly reject any bad plans that I might come up with and get moving on to the next plan. So I really want to be keeping a careful approach of monitoring my time with this problem. All right, let's jump into the planning stage for this. This is where I want to introduce the concept of heuristics. Let me bring up my heuristics list. And everybody should have their own heuristics list. It's something you build up over time. It could be a list of heuristics. It could be an order. It can be like a grouping, like mine. This is one that I wrote. I call it cut shorts. It really is heuristics. And what makes a list a heuristic? So on the right-hand side, I have my difference of squares, product sum factor. That's just a list of methods that I've learned over time, completing the square. What makes this a heuristic, though, is that I have the constraints and the criteria that make me decide when to take that action. So when I want to, let's say, for example, I want to do completing the square. Well, usually the only time I'm using that method is when I'm asked to put a formula into vertex form. So it's really interesting. I kind of have that little clever one clue that tells me when I want to use that method. And so that's what makes it a heuristic, that there's a set of constraints and criteria that help me decide when to use the method. I've also used kind of like a dirty tree method at the top level. I've grouped them into things that are obvious based on these criteria. The polynomials that to me are very obvious are ones that have maybe the coefficient is 1, the other coefficients are small and factorable, the degree is, I would even say quadratic or less. These are just little signs that make me know that I'm going to be able to quickly get to the answer on this, and I can use a very simple method to get there. And then I came up with a set of clues that are for the polynomials that are more complex, and then everything else. So that's the order I tend to go through. But again, this is my heuristics list, and this is what I would do. So let's see how this works when we're solving a problem. So the problem that I have, we already understand it, and we're trying to come up with a game plan. So the first thing I might do is I might actually go to my heuristics list, and I might think about, where does my polynomial fit into these criteria and constraints? It's definitely not one that's obvious, so I don't even need to look any further there. I'm going to move down. The ones that are complex, so far at least my feeling is that this polynomial is a complex one. It's not asking us to put in vertex form. It's not, the number of terms is 4 or more. That's a constraint. Factor by grouping is what I would typically do as my method whenever I come across an equation with a number of terms of 4 plus. Well, I think that's a great first attempt to try to solve this problem. So what we're going to do is we'll write down our first plan, which is factor by grouping. And we can, we can take this polynomial and copy it and bring it down here. And we'll paste it in, how can we group this in a way that it would make it enable us to be able to solve for y? Well, maybe we could take out the y out of these two, because usually grouping, what I'm trying to do is group these, pair up the terms, and then work on them as pairings. So maybe for this one I can take out the yx, and what I'm typically looking for is something that's going to be common within the factor. So if I take out the yx, I end up with x plus 2 over here plus x minus y. There's nothing really that I can do over there, though, and that doesn't get me to x plus 2. That's not really helping me. I'm starting to wonder, is this really helpful or not? Let's try one more time. What if we take the x squared y and pair it up with the x? We take the 2xy, pair it up with the y. Would that help us at all? Let's see, if we take out the x, and we end up with xy plus 1. We end up with plus 2. And we're taking out the y. We end up with x minus 1. That's not really helping. And I don't think bringing over the 2 is going to help either. You know what? I feel like I am chasing one of those wild mathematical geese that the author talked about. And so since I'm monitoring myself and I'm looking at this, I'm thinking, I need to have a different plan. And, it's good to use my heuristics, but it's also, I'm taking a step back, and this keeps sticking in my mind. I keep wondering, am I making this more complicated than it really needs to be? Y is 1 degree, and, this makes me think back to linear algebra, a linear equation, sorry, not linear algebra, that's a more difficult subject, but linear equation where, if we're solving for a variable, we just have to isolate that variable. So I'm wondering, am I making this more complicated than it needs to be? Let's see, should we just be isolating the variable? And the variable being y. I wish, actually, that was on my heuristics list. Maybe the clue would have been one clever clue, just if the variable is only 1 degree, well, then I need to isolate the variable. Well, let's jump in, let's not waste much more time, and let's give this a try. You know what? I can actually take this guy and bring this over here, and let's give this a try. Okay, so my first attempt, let's see. I am thinking I want to isolate the y, so maybe I'm going to, let's see, bring over a y, plus y here, plus y here. Then I'd end up with x squared y plus 2xy plus x is equal to 2 plus y. Then I could pull out the x's. Because they're multiple degree, I don't think that's really helping me. Let's see, because I end up with, if I factor out the common x across those three, I'd end up with xy plus 2y plus 1 is equal to 2 plus y. I think, again, I think I'm heading in the right direction, but I think I might have started down the wrong path. Let's see. What might be a better y? I want to isolate y. So maybe it's better if I start to get the x's out of the way. So then I can factor out the y. I think that's going to work. Let's give that a try. I'm going to put a little line here. I'm going to put a little line here. And I'm going to try, let's see. I'm going to say x squared y, that's bigger, plus 2xy, and then I'm going to say plus x minus y. I'm going to minus out that x on this side, and I'm going to minus that x on this side. Okay, so this is going to, in a sense, cancel this out. So then I have x squared y plus 2xy minus y is equal to 2 minus x. I'm starting to see something good here. So now if I take out the y, factor out the y out of this side of the equation. See, you've got y, x squared, plus 2x minus 1 is equal to 2 minus x. I can already see how this is going to isolate the variable y. So I feel really good about this approach. So I'm going to say y is equal to 2 minus x over x squared plus 2x minus 1. And I got it. I've got the answer for y. Okay, so let's make sure that we're answering the ask. Again, we needed to solve for y, and we needed to solve it for this problem. We can even go back to the original question. Make sure we're asked to solve the algebraic equation, x squared y, 2xy, x minus y is equal to 2 for y. And let's see, that's what we did. Okay, I think I feel really good about this answer. I'm going to start looking back and reflecting on my work. And I like to use my checklist because it keeps me honest. Now, did I answer the ask? We already did that in our tryout phase. Does my answer hold water? Let's see, did I get the number and type of values that I predicted? Let's see what I thought I might get. Well, this is what I thought I was going to get. I thought I was going to get an expression for y, and that is what I got. I have y is equal to this expression, 2 minus x. It's a rational expression, 2 minus x over x squared plus 2x minus 1. So I do feel good about that. Did I remove extraneous values? Oh, that's a good reminder. I'm glad I put that in there. So extraneous values are where it can mean a couple of things, but in this instance, what it means is there are values that might appear to work for x, but don't work because they end up getting us to, I'm not going to use the right term right now, but it's going to get us to an invalid solution. And it has to do with down here with x squared plus 2x minus 1. We need to, I wonder if I can quickly get rid of the x, because this is very important. So we're going to cut that out. Good. Okay, so this has to be such that, let's see, such that x squared plus 2x minus 1 does not equal to 0 because we can't divide by 0. Okay, so I hope you see that, why that's an important part of this solution. We had to remove those extraneous values, and that's how we do that. Good list. So my list is really helping. How can I best check the answer? Substitution, distributive property. Well, definitely we could use the distributive property to multiply this back out. For the sake of time here, I'm not going to do that, but I think you can see what you would do is multiply y times x squared plus 2x minus 1, and then you have the 2 minus x, and you would move the terms back around and make sure, confirm that that is indeed the original problem that we worked with. Okay. And now I want to just think a little bit about what worked, what didn't work. I want to think about the path that I took. And I'm very happy with how that worked. You know, the author, we did have that warning that a lot of his students chase wild geese. And again, I did actually indeed chase wild geese by going after the factor by grouping method. So how can I stop myself in the future from going down that path? Well, I think, again, it points us back to the heuristics model. And what I should have here, and I don't know if I can quickly add this, but what should have been in here is a quick and clever clue. And I think it is that. It's part of those polynomials that are easy, that are obvious. And it should have gone up here. There should have been one that said is... Let's see. Cut, and then I just need my keyboard, and I guess we'll take this keyboard for now. For some reason, Notability sometimes pops that up. And the criteria that I might add for this my new heuristic is the variable is 1 degree. Okay, and the action that I would take, and let's just say here, that's the actual constraint. I've been highlighting those in the color green. And let's see, let's copy and paste, move that over here. The action that I would take whenever the variable is 1 degree, what I should be doing is isolating the variable. And unfortunately, where is, I could use my keyboard here. Let's do that. Isolating the variable. And this way, the next time that I get to a similar problem and I turn to my heuristics list, I'm going to see that one right up front. If the problem itself is just, I need to solve for a variable and that variable is 1 degree, well, the way I'm going to approach this is I have to just isolate the variable. And that's exactly how heuristics are supposed to work. Okay, so let me go back to the problem. So I've added my heuristics in. And how does my plan compare? I love doing this step because I like to see how I like to see how the author would have solved it. Unfortunately, the author doesn't provide the answer in his book. But, in lieu of that, I can go out to MathPapa, I can go out to Wolfram, Desmos. Those are wonderful tools for letting me see how other people might have solved this problem. So let's take a look at, I'm going to pick Wolfram because I think the last problem we used, MathPapa. And I'm just going to type in the problem. Wolfram doesn't do a great job at using the copy-paste function, unfortunately. But we're just going to do x squared y plus 2xy plus x minus y is equal to 2. Okay. And then I'm going to hit enter. And let's see what Wolfram would have done. Okay. See, unfortunately, Wolfram used to give you a nice graph even, and now I think that's a pay-for function, but that's okay. Because look right here, I'm wiggling it around a little bit. That's the solution. Y is equal to 2 minus x over x squared plus 2x minus 1. And that's exactly what we got. And you notice on the left-hand side, he also put the condition such that x squared plus 2x minus 1 does not equal to 0. So now I know I'm doing a great job with this problem. We look at MathPop, and they actually would have shown us the steps too, and we could have compared and seen, did we take the best steps to get there? So we examined the path, we compared it against another tool, and I just want to make sure, how did I do as a problem solver? Did I manage my resources, chase wild geese? Well, I definitely chased wild geese, but because I managed my resources, I quickly rejected a planned approach and moved back and came up with a better plan. And I feel really good about how I managed my resources, my time, my accuracy. By using the checklist, I was able to ensure I got an accurate answer by adding in, removing the extraneous values. So I feel really good as a problem solver. So where do I need to improve? And this is really important, to be really honest with yourself about what worked, what didn't work, what do you need to improve. If there was a skill set, maybe you didn't remember how to isolate the variable. Well, you might want to go back to Khan and relearn that skill set. And then you would just, simply write out, in your plan, you could put it here, or maybe you have a daily planner, or you can use, the planning sheet that's included in this packet. But all you want to do is make sure sometime within the next week that you review how to isolate a variable. It's that simple. If there's something in the problem-solving approach that you felt didn't work, you want to redo that. Now, the last thing that I would definitely recommend doing is you want to try this problem again. Now, if you didn't try this problem before we solved it together, you definitely want to try this on your own ones. But if you've tried this and now you understand how to do this, what I do recommend is trying to solve this problem within 2 to 3 minutes. Okay, because when we're initially trying to think about the problem and understand it, we want to explore it and we don't want to limit ourselves with time. But then we want to make sure we really understand it and can just quickly understand what the problem is, pick the best heuristics, act on the best method, and get to an accurate solution as efficiently as possible. So I hope out of this you believe more that the structured approach is more efficient than just jumping in and doing anything. There's so many different directions we could have taken, and as the author said, a lot of his students went out chasing wild geese and they didn't monitor themselves and reject plans, and they really weren't sure where to focus. And hopefully this structure you now start to believe in and can start to make more use of it moving forward. So please feel free to make any comments or post any questions, and I look forward to working with you through the next problem-solving experience. Have a nice math day.